In this video I will show how to use OpenCV in Unity Android app. I will create a Unity C++ plugin in Android Studio that will enable this functionality. Watch the above video for more information on that. Starting with getting Unity Webcam texture to C++ plugin and extracting features from it using OpenCV. I will also discuss how to draw this features on camera frame and get the feature information back to Unity. Finally, I will show how to create a face detector using OpenCV for an Unity Android app. We will follow the same procedure as previous video to integrate OpenCV with Android Studio. I have already made a video on that along with another video on how to use OpenCV with Android using C++, please go watch it. This is the Android Studio project from OpenCV for Android, C++ video. First start by creating a new module, go to File, New Module. Select Android Library and change the config accordingly. Click on Finish, this will create new Android Library module and all files required for the same. Now left-click on the created module and click Add C++ to module. Select the C Makelist option and click on OK. This will create all files required for creating a C++ shared library. I have already discussed what these files are and what they do in previous videos. Link to all videos will also be provided below. Now go to the cmakelist.txt file, here we have to find OpenCV and integrate it with project, for that use find package. Then in target link libraries, link the OpenCV libraries to your shared C++ library. Now go to build.gradle of the newly created Android library, here inside Android, default config, external native build, cmake, add arguments and targets. Set the target to the name of C++ module from cmakelist. Add the argument for OpenCV directory, here you need to provide OpenCV path. Here you can see the OpenCV Android SDK that has been downloaded in previous video, inside it go to SDK, native, JNI. Copy and paste the path for the JNI folder as OpenCV path in build.gradle. Also add argument for which Android toolkit to use. And set standard template library to C++ static. Now click on Sync Gradle, this should link all the libraries properly. Now go to the C++ file, include all the required dependencies, which in this case are, JNI, core, improc and features 2D from OpenCV2. Along with vector and string. Set the global namespace to CV. Create a extern C declaration, this will contain all your function to be called from Unity. Here first create a OpenCV matrix camera frame, that will hold your camera frame received from Unity. Create another function, init OpenCV frame, which takes the two integers inputs, width and height. Inside it initialize the OpenCV mat with input width and height, and of type 8-bit and signed integer with 4 channels. This will hold the RGBA texture 2D received from Unity. Create another function that takes input as the pointer to the memory address where your texture data is stored. Now inside the function first pass this address and set the data of camera frame OpenCV mat. Then create a OpenCV matrix gray, convert the camera frame to grayscale and store it in gray, using color. Create a vector of type .2f, corners, to hold the corner information. As in previous video, use good features to track function to extract features from the camera frame. First pass the grayscale image as input from where the image features will be extracted, the corners vector, the number of max corners, the minimal quality level to be accepted by the detector, the minimum possible distance between two markers, mask if any, the block size, and whether to use Harris corner detector. Now for all corners, draw a circle at that point in the frame. Use circle for this, pass the input RGB frame where the circles will be drawn on, then the point where to draw the circle, the radius of circle, the color that is green, and the thickness of circle. Now build the plugin. The output will be inside Build, Outputs, AR, inside your created library directory. Open your Unity project. Create new folder, inside it create a new scene. C# script, CV Manager. And Plugins folder. Go to the Plugins folder and copy your build AAR file here. Also go back to the downloaded OpenCV SDK folder, inside it go to SDK, Native, Libs. Here inside each folder you will find OpenCV shared library for different architectures. Copy everything inside this libs folder into your plugins folder. Now open the C# script, add the runtime interop services to access external C++ library. Create a constant string to reference the library name, which can be copied from the cmakelist.txt file. Use DLL import to include the init OpenCV frame method, referencing the C++ equivalent for the same in the C++ library. Do the same for getFeatures method. Here input to get features will be the reference to the color 32 array, raw data, which is 8-bit and 4 channels as defined in C++ script. Create a new texture 2D, camera texture, and webcam texture. Also create a raw image variable. Here I will pass the UI raw image to display it on screen. You need to include UnityEngine.UI for this. Inside the start method, first initialize the webcam texture with some width, height, and FPS. Then call play method to start the camera. Initialize the camera texture with same width and height as webcam texture. And pass it to the texture of raw image. Create a new method process OpenCV frame. Also create an array of colors 32, raw colors. Inside the process OpenCV frame method, first get the colors 32 array from webcam texture, which gets the color 32 value for each pixel in the texture, and assign it to raw colors. Next pass them as reference to getFeatures function in C++. And finally set the raw colors to camera texture. What this effectively does is, first we get the texture data from webcam texture, pass it to C++ for feature extraction and draw circle on that frame data, then we pass the modified data to camera texture and show it on screen. Now call the process OpenCV frame method in update. Finally we will call the init OpenCV frame inside start, passing the width and height of the webcam texture. In the Unity scene, create a UI raw image. Add the C# script to any game object and pass the raw image to it. Also modify the raw image to cover the whole screen. Now build the APK. There are some errors related to OpenCV library. For that, go to Plugins folder and for every library set their proper CPU arch. For example, for OpenCV library inside ARM64 set the CPU to the same, ARM64. Do this for all architectures. Now build the app. Here in screen you see the image features being detected and marked on screen as green circles. Now I will get this feature information, that is the position of each detected feature, back to Unity and not just drawing circles on them. Go to Android Studio, C++ file. Here create a new struct, corner info, which will have two integer variables, x and y, for the x and y position of corner on the screen. Go to Get Features function, here add additional input, which is pointer of type corner info. Inside the loop where circles are drawn, create a reference to a single element of corner info, and update its x and y values respectively. Now build the plugin and similarly copy it to Unity plugins folder. In the C# script, copy the same struct corner info, and make its members x and y as public. This is required in C# to access the members. Also, where your get features is declared, add another input, which is int pointer, point. Now inside process OpenCV frame method, create an unsafe declaration. Also create an array of corner info, corners, and initialize its length to 20, which is the max number of corners declared in C++ good features to track. Then inside unsafe, create a pointer of type corner info and fix its address to the corner info array. Inside it call the get features function from C++ with additional input parameter, which is corner info pointer type casted to int pointer. What this does is, first we create a corner info array and pass its address to C++. Then when corners are detected, C++ updates the value for each element of the array, which can then be accessed in Unity. Now output the x and y values of 0th corner as debug log. Now go to player settings and select Android. Here check for allow unsafe code option, make sure it is on and selected as we used unsafe keyword in C# script. Now build the app. In the phone screen you can see the corners being detected and the position of first corner as output in logcat. Now we will move to detect faces from Unity Webcam texture. Go to C++ file in Android Studio and first include obj detect. I will be using a HAR cascade-based face detector. Create a cascade classifier variable, face cascade. Create a function init face detector that will take the path of model as input and load it into cascade classifier. Create another function detect faces which takes input as the pointer to the memory address where your texture data is stored. Similar to find features, pass this address and set the data of camera frame OpenCV mat. Then create a OpenCV matrix gray, convert the camera frame to grayscale and store it in gray, using color. Create a vector of type rect, faces, to hold the face information. Use face cascade.detect multiscale to detect objects of different sizes, which in this case faces. Pass grayscale image and faces vector as input. Now for all faces, draw a rectangle at that point in the frame. Use rectangle for this, pass the input RGB a frame. Here provide points P1 which will be the top left corner of the box and point P2 which is bottom right corner of the box. The color, that is green, and the thickness. You can also pass this face information back to Unity. Similar to features, you can create a new struct like corner info with addition members for width and height and follow the previous procedures to update the data from C++ and get it to Unity. Now build the plugin and copy it to Unity plugins folder. Go to C# script, include the detect faces function from C++. Also include the init face detector function too, with string as an input. Go to Unity Editor, create a new folder Streaming Assets. Note the name should exactly match along with caps. Here inside Streaming Assets you need to place HAR Cascade model files, which can be downloaded from here. I will be using HAR Cascade frontal face default. Go to C# script, here inside process OpenCV frame method, comment the unsafe part as we will be using only face detector. Similar to get features, call the detect faces method from C++ and pass the reference to raw colors as input to it. Now inside start, create a string variable file name, which will be file name of your model file. Include using system.io. Create another string variable file path which will be the path to your model file. Here we need to have the model in persistent data path for it to accessed by C++ plugin and load in Cascade classifier. Check if file exists in that path, if not then we need to copy that file from Streaming Assets. For that include Unity Engine.networking. Create a new method copy file. First create a Unity web request to get the file from streaming assets, then send the web request. Wait until this process is done. Then copy that file to the path in Application Persistent Data Path. Now call this method inside start, passing file name and file path where to save it. After that call init face detector from C++ passing the same path as input to it. Now build the app. On phone screen you can see the faces are being detected and green rectangle is drawn around them.